Hello everyone! Today we were going to talk about how to use Python to do forecasting. So first, you need to install Anaconda Navigator. And then we need to install our module not belong to Anaconda Navigator. So we install. Just click cmd, launch it. So type pip or pip install pmdarama. We will use it later to our program until it says successfully downloaded, and then also install pip install semopy. Enter and wait also to say it successfully installed. And then let's go to our program. Now we need to gather data that has seasonal and trend. So I already gathered mine. So let's check it on Excel. And this is my data. It has month, year, date string, production, and this is the line chart of my data. So it has seasonal. Look, we can say it has seasonal because it's look like they copy it like that, and has a trend. We already make our data, already fix it or edit it. So let's go. I'm also save this Excel on CSV file. And CSV file, I already saved it. So let's go to our Navigator again. So let's go our Anaconda Navigator, then launch Jupyter notebook, launch. Let's open. So wait, I already make my folder, so you can make your own folder. So it's here, download my forecasting folder. So I already download my CSV file here, so you need to just click upload and then upload your files here. And then to start your program, just click new Python 3. So after you click the Python 3, it will show you this blank page. So let's try. Print hello world. Look, it's print here. So let's go. I already make the program, so I will just explain. So click, this is the program. So this is the program. So first we need to import our data. So import pandas as data. Pandas is a module. So we import pandas here as a PD. PD is a code for us to call these pandas. So data frame production, you can change this anything you want to name your data frame. Equal pandas, or this PD, our code that read CSV monthly milk production .csv. So this panda, this PD is our code to call these pandas. So after that, this monthly milk production is my CSV file. So let's check this one. You can see monthly milk production CSV. If you type wrong, it will be error. So for example, I'm sorry. See, name error. Yeah, so you can see error. You can see the error. So wait, let's just run this pandas. So here it says our error, no such file or directory monthly milk production, because we typed it wrong. So let's just correct it. You should always check. This is the good thing to Jupyter Notebook, because he will say, or it will say, what's wrong with your program. So here we install our file. So let's just see, it is already here. So data frame production.head. So click to see the first 5. Let's see, this is my file. So let's see what's inside here. So the month, year, date string, production. Let's see, here it's already here. So to see, it's all here. So let's see the last 5. So data frame production .tail. So let's run it here. You can see this is the last part, the last 5 of our data frame. So now if you want to see all of the inside of our data frame, so let's just print data frame production .toString. So it's all here, what's inside our data. So let's just check. It has 168. So let's check to our tail. 168, you see. It's already here. Then now you can see we have a data string here, but it's not the real data that we needed, or the real data. It's look like the date. I'm sorry for the date. So it's okay. And then let's just make another column that name date. So let's go. Data frame production date. You can change this. You can change this anything you want to name your column. So pandas.to date time. Data frame production date string. This column that you want to change to real date or date we needed. Date string. You should type this correctly. If it has a space, then put space, because it will error if you don't do that. So let's check it if it has a column here. So data frame production.head, it will paste. Here, look, we have now a date column. After this production, our data string. Here we have now our date. And now you can see this program has a index, automatical index from 0 to let's check, to 167. So now let's say that this column date, we will make it the index of our data string. So just data frame production that set index date, this column date in place true. Then let's see if our data column is our index now. So data frame production that head, so it will paste, it will show us if it's true. Here you can see our date column is now become our index. So the production 595 is now the 1962 January 1. We make our date to be as in our index. So let's say that our index, our frequency index is a month start. You can say that year ends, year start, but we will use the month start. So definition, no, data frame, sorry, data frame production that index frequency equal month start. So let's run it. Then now we will show the plot, or we will going to time plot. Now import matplotlib.py plot as plt. As I say, like the pandas as pd, this plt is our code for matplotlib.py plot, because it will become complicated, or we just do this to look nice, our program, or to make it easy for us, because you need to type this long. So let's just make this code, so plt. So now let's go. So data frame production, our data frame. So production, we will now plot our data string. So this production. So that plot, figure size 20 by 5. Now plts, or matplotlib.py plot, title production, or what you want to title it. So size 24. You can change the size you want. So plot.show. So this plt.show will show the plot we make. So let's wait. You can see the plot. I'm so sorry. So this plot production. This is our plot, like the we make on Excel, the line graph, like that. You can see. And now let's decompose this what we call this data string. So from stat models, time series analysis, seasonal, import seasonal decompose. So this seasonal decompose belongs to this stats model, time series analysis, seasonal, is from this module. So we will going to use it. So import seasonal decompose. Result equals seasonal decompose. Data frame production, the production column, then model add. So result that plot, it will show the result when we program. So let's run it. So wait, because it will takes too long here. This is the look like line graph. So this is the graph that we already graphed kanina. So now we have trend. We can see the trend is go upward. And now the seasonal, look, see, it's like a mountain that twin, or actually magkakamuka, like that. Then residual, it was scattered. If this seasonal, it looks like this. We haven't a pattern, so it was scattered. Now let's perform ARIMA. As you can remember, I told you to install the ARIMA, so we can use now. So from pmdarama, we install import auto ARIMA. Now this auto ARIMA belongs here to pmdarama module. So now we can use it. Auto ARIMA, data frame production column, seasonal is equals true, M is 12, then summary. So let's just enter, run. So let's wait. It will take too long. So let's just wait. Thank you for listening. I'm sorry if let's just wait. Sorry for the noises. So sorry. Just wait. After this one, we will ayan, it's print the summary. So the number of observations, 168. You can see, if you can see to our data frame. So we have 168 here, 168. And then the model of Sarima X or Sarimax. Date, time, sample. So now let's move on. Let us perform data partitioning. So N is equal length of definition. Data frame production. I'm sorry. N, then we print the N. 168. The length of our data frame production. This is the length, 168. I already showed you this in the number observation. So here, 168. And start index equals n minus 12. So it will we will decrease the index. So start index, it will print now 156. So let's see. Data frame training is equal data frame production dot eloc start index. Data frame test equal data frame production dot eloc start index. Now let's see. So data frame training dot tail. So let's print it. Let's show. As you can see, we have this 156 are data length. These are data frame length. You can see here we already says that 156. So let's go again. Let's check. So length of data frame training 156. Here you can see this T, so the length of our the frame. So let's summary the result of our Sarima or Sarima X from stats model time series analysis state space. So that Sarima X import Sarima or Sarima X. So we can see that this module, so this package, import Sarima. From this package, we will use Sarima X. So module equal Sarima or Sarima X, Sarimax. Data frame training, the production column, order 200. Then the seasonal order is 11012. The result equal model fit, model.fit, result summary. So it will show the summary. I'm sorry, I didn't run this from stats model. So let's run it and then run. You can see now we have our observation 156 here. So this is the summary. Late sa nauna we had 168 and now we have 156 number of observations. So let's move on. So now we need to obtain our predicted values and perform the measures. So start equal length of our data frame training and the end length of our data frame training plus length of the data frame test minus 1. So prediction is equal result that predicts start to start, end to end dynamic false type level. So let's run it. Our program has our predicted values. So let's just see. So let's print it. Predictions. Just type predictions. This is only prediction with the test only. The test set only. So we have here 83.558, like that. So now let's predict our expected values. So for I in range, length, predictions, print F, predicted, prediction I, expected, the data frame test, the production column. So let's see. Let's run it. So now we have, you can see, we have the our predicted values and expected values. So now we need to comparison between these predicted values and expected values. So we make our title. So title is equal monthly milk production. You can change this, the title. Y label also. So milk production, because I will make the monthly milk production. And then here, data AX is equals to data frame test, the production column, dot plot, legend, true, figure size, and title. So prediction dot plot. Then AX auto scale. Then AX set. So let's see. Let's show. See, you can see. This is the plot of our comparison of our prediction and expected values. So we already fit the model. So just So now let's perform MCE our MCE. So from sklearn matrix import mean square error. So this is the error. So MSE is equals to mean square error. So mean square error is from the module sklearn matrix. Definition data frame test production. So the data frame test production column. So prediction print F sarima 2001112. So the MSE error. So let's run this. So our error is 150.160. So let's now compute the root of MSE, our measurement. So just getting the square root. So import math.square root MSE. So let's run it. 12.25. Now we have our we have all we needed. So let's just print it all. So model.sarima x definition data frame production order 200 seasonal order 11012 result equal model fit forecast result that predict length data frame production length data frame production plus 11 type levels rename Sarima X or Sarimax 2001112 forecast. So let's run it. So we have already. So let's see if we have this program. This program have it now. So forecasted value, enter. So now we have here our forecasted value. We already forecast now. So let's save it on our file. So just type forecasted value of fcast that to CSV. This forecasted value. This is what you want to name your file. So you can change this if you want. So let's run it. Enter, and then you will see this. This is our file. Let's see. We already saved here it. So let's look at it. These are predicted value. This is our forecast now. Sorry for I say that predicted value. This is our forecast. Now let's see the graph after we get this forecast. So here my Excel. This is the production. So I already make my line graph, so we can see. So sorry. Let's see. I'm so sorry. Here. Here. You can see this blue line graph. This is our production, and this orange one, this is our forecast. You can see we make it, or we done it correctly, because it look, gumana siya na maayos kasi nadugsong siya dito, and makikita naman natin na tama yung forecast natin kasi kamukhang kamukha ng mga nauna. So good job everyone. So thank you for your time. Thank you. Just save it as CSV file. So to save your what we call Jupyter program, the Jupyter program, you need to install make text and pandoc, so you can watch the tutorial on how to fix it, and then save it. Thank you everyone. So this is all for today. So thank you. God bless, and I hope I explained it clearly. I'm sorry. Thank you.